Hi, this is Dorothy Dow. In this video, I'll be showing you what De Moivre theorem is and how to use it to solve a problem. So, first let's start out with how to use De Moivre theorem to raise a complex number to a power. So this is your formula right here. This is the formula you use to raise your number to a power. So this is it. This is the original formula. So now let's start with our first problem. Okay, so for your first problem, they're asking you to evaluate square root of 2 plus square root of 2i to the power of the fifth. So now to start with this problem, first you have to find your r, because for De Moivre theorem, your formula or your number have to be in polar form. And this number right here is not in polar form, so now we have to transfer it into a polar form. So now let's start out with your r. Okay, to find your r, you have square root of 2 square plus square root of 2 square. And this number, the first one you square is your normal part, your normal number, and you square it up, and you add it in with your imaginary number, and you square it. And this right here will give you square root of 4, which you know is 2. So that's your r. And after this, you're gonna have to find your theta. Okay, so to find your theta, you're gonna have tangent inverse of your normal number, which is square root of 2 over your original one, which is square root of 2. And then after that, it will give you, I believe, 45 degrees. You can just do this by looking at your unit circle, or you can just put it in your calculator and it will give you the exact number. So out of all these numbers, your theta and your r, it will give you the formula of C equal 2 cos 45, which is your polar form. And now you can start with a problem. Okay, so now you will just make it so it can be to the power of the fifth, because this is what your problem wants you to be. So now you take your formula, which is 2 cos 45 and to the power of the fifth. So then you just use your original formula, which is right out here, but instead of cosine and sine, I'm just gonna make it simpler, which I'm gonna make it cos. So you're gonna have 2 to the fifth cos 5 multiplied by 45, which is your theta. And this right here, if you plug in your calculator, it will give you, I believe, 32 cos 225. And this is in polar form, or you can also call it in trig form. So, but the question right here, it was asking you to put it into standard form. So now we have to translate into standard form. It's not that hard. Okay, so you have to take your formula out. So then you're gonna have 32 cosine 225 plus I 32 sine 225. And if you plug these numbers into your calculator, you will have, I think, negative 16 square root of 2, which is this part will give you, plus plug this part into your calculator and you will have the same thing. Oh, I think this is negative. Sorry. It's negative 16 squared of 2i. So this right here is going to be your standard form. And every single time you finish your problem, you should box it so it's gonna look clean and neat. And that's what all of the math teacher want you to do. Okay, so we finished with the first part, which is using De Moivre theorem to raise a complex number to a power. So this formula right here is literally all you need to use. But your number needs to be in polar form for you to use it. And this is how you solve the problem. So you just, if your number is not in polar form, you need to translate it into polar form. So you need to find your r and your theta, and then you just put it again into your polar form. And then you can start with your problem. So you just plug it into the formula that I gave you, the original formula right here, to this formula, and you just calculate it out. And it's gonna be in polar form. But if your answer wants you to write in standard form, then you just need to translate out. So just plug it into your calculator and get out a number you want it to be. Okay, so that's your first one. Let's start with the second one. The second one is to use De Moivre theorem to find the roots of a complex number. So this is your original formula right here. And this formula is used where k is equal 0, 1, 2, blah blah to n minus 1. So that's what your formula is going to be. That's like one way to use it, but there's also another way that's going to be much more easier for you to use. So the problem wants you to find the third roots of z equal 5 kiss 30. 5 kiss 30. So for this particular problem, since you need to plug it into a formula, so it's going to be much more easier if you write your data out. Okay, so let's write out what your problem gave you. Okay, so you have, let's see, you have r equal 5, theta, which is right here, is equal 30. Your n, since we need to find the third root, so it's gonna be 3. And your k is going to be 0 because, as you remember, your k right here, the original one, needs to be n minus 1. So instead of root 1, you will need to be 0. Start with 0 and 1, 2. Okay, for k, since you're gonna have third root, so 3 roots, then you will have 3 answers. Okay, so that's your data. Now let's start with the problem. Okay, for this problem in particularly, I like to use another way to solve it. And it's gonna be much easier and simpler for you to use it. Okay, so you're gonna have 2 steps. Your first step is where you're gonna use the formula I will give you right now. So the formula is going to be z0 equal r to the 1 over n kiss theta over n. So that's the formula you will always use to find your z0, and that's going to be the first thing that you will find if you want to solve this problem. Okay, so let's plug your data in. Okay, so your z0 is going to be equal, okay, your r is 5. So 5, 1 to the n, your n is 3 right here. So it's 3, 1 over 3, kiss. Your theta is indeed 30. And your n is equal 3. So if you plug it into your calculator, it will give you 1.7 kiss 10, since it's 30 over 3, so it's gonna be 10. Okay, then the second step, which is your last step, you're gonna add into your theta 360 over n, and this is the second formula you will always use for this problem. Okay, so for your problem right here, if you plug your number in, it's gonna be 360 over your n is 3, so that it will give you 120. So now let's find your z1. Your z1 is literally just going to be 1.7, and all you need to do is add your original theta or your theta of z0 to 120. So it's gonna give you 130. So that's gonna be your z1. Your z2 is going to be the same thing, 1.7 kis, and then your last theta plus 120. 130 plus 120 is gonna give you 250. So that's all that you need to do. But there's one more step. Remember, every single time you finish a problem, box all your answer. Okay, so z2 is one of your answer, z1, and then z0. Your square, your box doesn't have to be beautiful or clean and neat or anything like that. It just needs to be boxed, so your teacher will know where to find it. Because for some people, they just tend to like do their problem all the way, like everywhere, so it's really hard to find it. So just box your answer. Okay, so this second problem that I've been teaching you right here, showing you right here, is how to use De Moivre theorem to find the roots of a complex number. So this is your original formula right here, but you don't really need to use it. So this is the one that you're going to use. I mean, you can also use that one, but it's much more complicated. So I broke it out to these two formula right here. So the first thing you have to do for this problem is write out your data. So it's gonna be much more easier for you to plug it into your formula. So your first formula is the one for you to find z0, which are this formula right here. So you just plug your number in. So then it will give you what your z0 is. So the second step, you're gonna add in 360 over n, which is your second formula. It literally just broke down from the original formula, so nothing else different. But anyways, so then you just calculate it out, and then you find your z1. Your z1 is literally just gonna be the exact same thing, but you're gonna plus your original theta or the theta that you had before, and you add it in with 120, and that's when you're gonna have your z1. And your z2 is gonna be the exact same thing again. You just it's just gonna be 1.7 kis, and you're just gonna add in your theta before that and add with 120, which is the number you calculate out by your second formula, which is right here, 120. So you add it in, and you're gonna have a new theta, and that's your z2. And remember, when they ask you the third roots, that means you're gonna have 3 roots, and 3 roots is equal 3 answers. So that's what it is. So De Moivre theorem, it sounds really complicated, but it's not that complicated. So in this video, I've been showing you how to use De Moivre theorem to raise a complex number to a power, and how to use De Moivre theorem to find the roots of a complex number. So that's all I've been telling you today. So have a nice day, and thank you for listening.